Let's welcome the next speaker, Mike Grabowski, Universal React, talking about reusing JavaScript between React Native, React Web, and yeah, how to really write once, run everywhere. All right, Mike.
Hello, everyone. I also like to welcome everyone from the live stream. I know there are lots of people watching us, so I hope you're going to enjoy this. So I'm Mike, and I'm here today to talk to you about the concept of universal JavaScript and how, thanks to React and React Native, we can build our apps faster and make them more maintainable. Before we start, just a little bit about myself. I'm a CTO at that company called CodeStack.io. I've co-founded it last year to help companies deliver better React Native apps. And we do a lot of in the open source, and that's probably why you may recognize me from what I'm doing with React Native, React Navigation, and a couple of other repositories. We are also organizing a conference in September about React Native. It's called reactnative.eu. If you are interested in hearing more React Native talks, you should definitely check it out. And so at CodeStack, we have this great opportunity to iterate on products that already have existing version of the app done in the same language, usually for web. And that unique opportunity shaped the way I think about universal JavaScript and about the patterns that I find useful. And this talk is going to be inspired by the findings that we've been discovering over the past year. So let's get started. First, let's start with architecture overview of a typical app we are usually building. I like to think about those applications in terms of multi-tier architecture. It is a client-server architecture in which presentation layer, business layer, and data access layer are kind of physically separated. And the most widespread use of that architecture is the three-tier architecture with the three layers that I've just told you. And apart from usual advantages of a modular software with well-defined interfaces that you get, such architecture gives you the unique opportunity to upgrade or replace each of these tiers independently during, for instance, porting your existing code base over to a new platform. Naturally, there is no such an app that can reuse 100% of the code without compromising on platform experience and performance. However, this is what we are going to optimize for, and this is the best case scenario we are optimizing our apps for. So let's take a step back and think how we used to develop applications in the past. Because historically, it was never easy to reuse code. It is because we've been always developing our applications separately from within independent code bases. We've been kind of creating each of these applications separately, and that was resulting in features re-implemented in a different way, different sort of bugs being created for each of these platforms. And apart from these reasons, that approach is fundamentally broken for the following three reasons. First, it is expensive to target a new platform. For instance, take an example of Tizen. If you are into wearables and smartwatches, you know that Tizen is a Samsung operating system for smartwatches. And in fact, I'm wearing one right now. And by the way, this is not like a paid ad. And that operating system is really smooth and somehow feels better than Android Wear, in my personal opinion. The only problem that Tizen has is it lacks the apps. No one is developing for it. Everyone is targeting Android Wear. And the system itself is considered complicated. The second point is that it's slowing us down, as you need more and more developers, more teams to target all the platforms and develop these features at the same time. And that leads to inconsistent implementations and different sort of bugs that you then have to fix down the road. And finally, there is that platform-first approach, where you release, your, for example, iOS application first. And it's not only bad for your product, but it's also going to piss off your users, because if they feel abandoned, like, for example, take an example of Snapchat, that everyone knows that it's iOS first application. It used to be. And Android version was lagging behind iOS, like it was slow. I was unable to use it, and that was the reason I stopped using it. The only reason I installed it was that I was in beta channel and I saw that they fixed it. And so if you go with platform-first approach, you may piss off your users in a way that they will never try your app again and may even find a replacement. So that is important from the day one that you don't make that mistake. And personally, I think that one of the biggest problems and challenges here is that the language itself is not universal, right? Because it's tied to a specific platform environment. Like with Android, we write Java. With iOS, we write Objective-C. These languages have their own runtimes, own semantics, build systems, and syntax. And it's technically possible to share code between these platforms. You can write C code and reuse your low-level modules. And this is, for example, what Dropbox is doing. That, however, doesn't scale well, and you can't do it for web. So how do we solve it? Like, I wouldn't be standing here if the answer could have been different than JavaScript, right? One of the things that I like about it is that it's widely adapted and present almost on every machine nowadays. You can get productive with it very quickly, and it continues to grow in popularity as more and more developers are using it. One of the things that is very special about JS is something that we call the JS fatigue, which basically boils down to new frameworks coming out every day and every day. But I believe this is a unique feature that we have. Our vibrant ecosystem keeps looking for improvements, keeps researching, and keeps inventing. And that contributes to a rise of frameworks that are aiming to solve the code sharing problem. And one of them is React Native, and the entire idea of component-based interfaces. There are two things that I like about React here. First, I like that by learning React, I can write not only web applications, but now I can write iOS apps, I can write Android apps, VR, with Windows Phone, with more and more platforms to come. We don't even know what we will be able to do with React Native in the future. And the second thing is that I like how React encourages us developers to think better in terms of software developer. If you are like me, probably 2 years ago, you have briefly heard about functional programming. I didn't even do it on my daily basis. I was OOP down the road, stateful actions, and basically bad practices. Now, thanks to React, my stream on Twitter is full of immutable data structures, purity, functional programming, and I even started writing Haskell and other languages. So I like that React makes us better developers and opens up a lot of possibilities for us. And so one of the concepts that React popularized was the universal JavaScript that we are talking about today. And universal, back in a day called isomorphic, stands for the ability of your code to run on any platform, regardless of the environment. This term is often brought up in a context of server-side rendering. That means our React components are executed in the Node.js environment where they can prefetch their data, and the user receives a pre-rendered HTML output. And so that brings us to another stack, which is a stack of today. This is more or less what's happening right now in a variety of repositories and on Twitter. That stack embraces the idea of universal JavaScript, which is greatly inspired by the server side that I've just told you. It eliminates multiple independent code bases and favors a single unified source code that is meant to run on every platform. It builds upon cross-platform libraries like React Router or React Navigation and uses them everywhere to navigate your entire web application and your entire mobile application. At first, you may feel like this approach is superior to the one we have seen before because it fixes code duplication, because now we have a single code base. We can write all the features from the same place. And it eliminates the platform-first approach, right? Because we have the shared code base across all the platforms. However, at the same time, it unnecessarily complicates the code base. It employs a lot of workarounds and hacks just to get things working. Sometimes it even compromises on performance just to give the promise of your code being shareable across platforms. And a great example of such, not strictly related to React, is PhoneGap and Cordova, which, if you are following Twitter recently was brought up in one of rants about progressive web apps and all that mobile battle. And so the problem with PhoneGap is that you can take arbitrary website and put it as a standalone mobile app that you can deliver to your clients. That gives you that ability to just drop in your website, reuse 100% of the code, give to your users. But what about performance, right? What about gestures? DOM is fundamentally a different concept, and it was never designed to handle that complex gestures like pinch or rotation or whatever, multi-touch gestures. So these things and a lot of other nuances from mobile platforms that make up a great user experience we know are just hard to do that way. And that brings me to the fact that I feel that we keep missing a big picture here. Because we are all coming from web-based development. We keep talking about server-side rendering. And our mental model gives us the idea of sharing everything. Like with server-side rendering, our initial thinking is that we should just have our components execute on the server and the output is transferred, right? To me, universal JavaScript is different. Like, it's about code portability. Rather than thinking about how can I make my app run entirely on mobile, I should think what parts of my app are capable of running on a different platform, and how can I make them to contribute to overall application that will be done specifically for that platform. And so that brings me to the statement that we shouldn't build universal applications. They are over-engineered, over-complicated, and too much abstract. There is no silver bullet as far as platform sharing is concerned. And all boilerplates you ever saw that give you the promise of code reusability are fundamentally broken at the design level. You can't just take a pre-made solution and apply it to your different use cases and reuse your web app to a mobile app. And so instead of building universal applications, what we should really build are universal libraries and universal UI components. And so what does it really mean to build a universal libraries? It stands for designing our systems in a way that makes our API and logic run on every platform, regardless of the environment. And at first, you may feel that it's the same as universal JavaScript, but the difference here is significant. Because instead of focusing on making your application run as is on any platform, you start thinking how you can take part of it, like authentication logic, and make it to contribute to entire iOS, for example, app and a web app. And that contributes to a better development cycle within your product, because your developers, or you and your colleagues, can focus on solving specific problems, working inside modules, and making sure that the quality of your app is still at the very high level. So how about universal UI components? I didn't mention React as a dominant universal paradigm for no reason, right? One of its principles is that component-based model where you don't build an app. What you do is you build small building blocks and you compose them to create bigger and bigger and bigger components, whereas the root component is what you call an app. That's how you make it with React. And so building universal components means to focus on making those components platform agnostic, where it makes sense, and using them to create platform-specific solutions for your users. And that said, instead of focusing on reusing entire navigation, prefer using first-class router for the web, use React Router. For navigation on mobile, use React Navigation. But you are free to reuse the back button, right? Because back button is a small part of your app. Having it reusable is not going to affect the performance because touches and containers are very easy to port across platforms. So you shouldn't make compromises here. Presentation layer is very complicated, and it's very hard to reuse across platforms. You may feel that it's easy to reuse it because Android and iOS are similar. But if you're going to use React to, for example, create a VR app, it's going to get complicated. And so in this talk, I want to present you a stack of tomorrow, which is a set of concepts that I always apply over my code bases that I want to make universal. If you've been following this topic, I gave a very, very similar talk 2 years ago in Bratislava, and I ended up this talk by saying that there are 3 things that have to be fixed in order to make this a production-ready solution that can be very popular. And recently I was sitting and watching Twitter, and I've realized that we have made all these things. And so now that stack is ready for the prime time, and I'll explain why in a second. Of course, I'll share with you the reference implementation of that after the talk. So please follow me on Twitter. I'll be sharing the link there. But still, keep in mind, this is not a drop-in code that you can take. Instead, analyze the solutions there and think how many of them apply to your code. So, as I said, there are 3 main aspects of writing universal code in this approach that I wanted to highlight today. First of them is setup. And our code setup is very special for 2 reasons. First, we prefer universal libraries and user interfaces, single units of our app, over entire applications that tend to be quite complex. Ideally, we want to follow that multi-tier architecture that I showed you at the beginning and keep iterating on parts of our applications independently. Second thing that makes this code base special is the concept of utilities. I guess, like, how many of you have ever, probably everyone, created at least one folder called utils or utilities? Who's not raising hand is probably lying now, but OK, so the thing is that I like to think about utilities as to-be-published components and modules, right? If your utility is not ready to be in NPM registry or public on GitHub because it's tied to your application logic, then it's not really a utility, and you should think about how you structured your application. All that means that the way we are going to work with our code is going to involve a lot of independent, separate code bases and repositories, which can get difficult to track. And so to solve these and many other problems, we can organize our code into a multi-package repository that some of you may know as a monorepo. And projects like Babel or React already utilize that approach to make their workflow easier. And you can see the example structure on the slide that has 3 main folders. One of them is platforms. And platforms folder groups all the targets that you support now and you are going to support in the future. And there is the libraries folder, where all the packages that you want to publish in the future are going to live. And the core, where the shared logic is going to be located. And by the way, one of the great things about having libraries that you are eventually going to publish is the fact that you start thinking about the interface, about the API, and how your future users are going to use it, which makes you to think twice before you create a file, create another abstraction, which contributes to a better code base. And so if you want to automate the process of working with that code base, you are free to use Lerna, a tool that was designed specifically for empowering that kind of workflow. It has a bunch of commands. For example, you can run Lerna Bootstrap to automatically link all the repositories with each other, which makes this process really easy, this setup really easy to work. And so very important part of this entire workflow is Webpack. It's been quite last minute with Webpack because we've been working on bringing Webpack to React Native for quite a while. And I was working on that with Satya. You may know him, Satya164. He's also working with us at CallStack. And by the way, if he's watching live stream, we can now all say happy birthday, because his birthday are today. Yeah. So yeah, we've been working on that together for quite a while. And fortunately, we made it. And what's the buzz all about? So to compose universal modules and user interfaces together, you need a universal bundler like Webpack. And we know that Webpack is a powerful and extensible library that has a lot of features, including first-class support for symlinks. And so the entire idea of bundling system like Webpack is to take your application code starting from an entry point and serve a bundle. So if you are working with React Native, this is exactly what the React Native packager is doing. The only difference is that we wanted to use a single build pipeline for all the targets so that we can make it universal and reuse our configs. And so thanks to Whole, React Native can now benefit from that, and we can use Webpack quite easily with React Native to deliver pretty much everything that we can with web. And the last part of our setup, which is very important, is Babel. As I mentioned before, JavaScript is a widely adopted language. Now, that's only because it's been around for a while. The problem is that with every browser out there, you never know what's the target version that's supported. And for example, iOS 10 and iOS 9 and iOS 8 ship with Safari that has a different subset of features. And that's they ship with JavaScript core, which is running your React Native engine, or React Native code. And that Safari supports a different subset of features. For example, on iOS 10, it supports a full ES 2015 spec, whereas on iOS 9, it only supports a subspec. And so Babel is a great tool for that because it allows us to transpile our code to support any target that we want to run our application on. And so the transpilation is the process of taking our raw JS code, applying a set of transforms, and returning something that can run on React Native. And so there are a bunch of optimizations that we can do thanks to Babel. And thanks to using it here and web and other targets, we can reuse our extensions. There are two very interesting concepts that you can do. For example, with React Native, one of the performance improvements is that you can inline all the platform calls. You probably have been using platform module for selectively rendering some stuff in React Native, so these calls are inlined during the compile time. So now that we have a foundation for sharing our code, that's set up, let's take a look at common techniques for doing so. So the most important and the most basic approach is to use platform extensions, such as the ones that are allowed by React Native packager. This is crucial for creating cross-platform experience. It allows people to override default implementations by creating platform-specific files. The idea is that having an arbitrary file, like in this case index.js, you can create index.ios.js that will be specifically loaded on iOS to, for example, override the default tab bar. This works out of the box in React Native, and with Webpack, you can make it with resolve.extensions, which again brings us to the point that Webpack is a perfect solution for universally bundling our applications. And as far as presentation layer goes, I mentioned that it's kind of complex, and it requires us to think deeper before we start sharing things. One of the things that is important is to understand the different levels of sharing. There are two of them, and one is the local level. The local level is when you, for example, share your client-side React on server-side, or when you share your iOS with Android. You stick to the single environment, you're just sharing code between different devices, right? And this is easy. This is easy because for iOS and Android, you can reuse the entire UI. I'm not talking about user experience now. Like performance-wise, no differences here. You can just use it. However, at platform level, things get quite complicated because you have to understand that not necessarily everything that you know from web or React Native or mobile can be run at the same time on different platforms. So the answer to that problem is that we should use primitives over platform-specific controls. And so the problem is that if you want to really share your user interface component, you don't want to implement it n times for n platforms, right? You want to create it once for all the platforms, and that's what primitives are for. To better illustrate that, consider this example where I'm creating a component that's essentially just a wrapper, right? This component, what it's doing is wrapping my children with a div tag and applying some sort of styling, ABC. Problem is, I'm using a host component, I'm using DOM div component, which is entirely breaking the idea of code sharing, right? There is no DOM-related thing here. It's just that I use div tag. It's no longer going to run on a mobile. And so the idea is to use a generic wrapper, kind of like a view, that can adapt its behavior based on the platform and make it easy to build generic environment-agnostic unit of interface. And there are various implementations and takes at this problem, including recently open-sourced React XP by Microsoft that I encourage you to check, and React Native Web, which is a parallel implementation of React Native meant to run on web, and React primitives that I'm using in this example. So sometimes when all we need is just a simple wrapper, like in this case, using an entire library is probably not efficient, and what you can do is you can use the file extensions solution that we've seen before. So that's all about presentation layer, and as far as sharing of layers goes, there is also business layer. And business layer is quite easy to share because we can take advantage of JavaScript. JavaScript is running on mobile and on web with no differences, so we can quite easily share the code. And to better illustrate the approaches, let me tell you two examples that I highlighted here below the heading. One of them is the async storage module that we made at CallStack, which takes the async storage from React Native and local storage from web and integrates both implementations into a single library. It abstracts away the differences for you, errors, and all the other APIs, which means that you can use it regardless of the platform. And the second one is React Navigation, where all you have to do is React Navigation, where what we do is we take a single code base and we ship a web version that contains the logic, and we ship a mobile version that contains also tab view, drawer, and stack, which are mobile-specific user interfaces. As far as sharing your business logic goes, you don't have to use Redux, but I'm mentioning it here because I like to think of Redux as a protocol for sharing business logic. It externalizes your state, it moves your state away from React, which makes it easy to switch the DOM layer to something entirely different. Not only you can switch from web to mobile, but also you can switch from React to Vue.js or entirely different framework, even vanilla.js in Electron app, depending on what you are targeting. And another thing that I like about Redux is its simplicity and extensibility, because it has that concept of middlewares. And so if I have an async action, as in this case, I want to fetch user details, I want to use a fetch library on web and mobile, but for example, from terminal, I want to use a command line to fetch a certain resource for me. So having the ability to inject context to your actions, like in this case, allows you to change the dependencies on per environment basis. And even if you don't need it now, all you have to do, it also helps you with testing. So the takeaway for today is that code mobility is important. Not only you should be able to rip off any part of your code and replace it with another one. In today's world, you should also be able to target new environments and platforms without rewriting things from scratch all over again. There is no universal pattern or paradigm to that problem. Our code bases are different, clients have different ideas, and most importantly, technologies change. So I encourage you to innovate and keep looking for that optimal solution. Thank you.
All right.